Hi, my name is Matthew Thayer, and I'm going to be talking about what Master Machining Tool is doing to become a lean organization. First off, a little bit of background on the company. It was founded in 1954. We are also ISO 9001 certified, and we are a machine shop that with a concentration in manufacturing, engineering, and CMM certification. Some of the products that we produce are gauges, fixtures, leak testers, and a number of different special machinery. And a little bit of background on myself, I'm the manufacturing manager of the company. Now, first off, we are not a lean organization, but I'm looking to change that. Some of the goals that we have in mind are with regards to customer satisfaction, our quality, costs, and delivery, which we take much pride in as of before becoming a lean organization. And we're going to be working on continuous improvement by eliminating muda, increasing productivity, improving already great quality, and cutting costs. Now, some of the flaws that when first entering the shop are it's filthy. There's no lines painted on the ground. The offices are messy. If you look at the stock on the shelves that we have against one of the walls, there's an excess of inventory. This is a result of a push system and overproduction. And another flaw that we have is overprocessing of parts, along with much other excessive muda. As you walk around, you would notice that. Some of the things that we're working on doing on becoming a lean organization are implementing 5S, just-in-time production. We're going to be looking at evaluating TIMWOOD, which is the 7 areas of waste, implementing PDCA, Plan, Do, Check, Act, which is a base for continuous improvement, implementing some value stream mapping, and critical path method for all of our jobs or projects. Now, first off, 5S is a visual management tool. It provides a clean, well-organized workplace, makes problems visible so that they can be corrected. Now, 5S stands for sort, set in order, shine, standardize, and sustain. And I'm going to go into that a little bit more in depth. Now, first off, implementing 5S is going to have to do with overcoming some barriers. Barriers like management and higher than myself, because I'm trying to implement this. More along the lines of the owner of the company tends to leave a mess. He backs batch production and over processing of parts, and it's really going to take the influence of me and other workers to and encourage a change, and that's one thing I'm going to be working on. Now, first off, we have sort. The shop, there's unnecessary machinery and equipment that can or has already been removed, and we're really getting into removing all unnecessary equipment. And we're scrapping all unnecessary materials that are just laying around the shop, not being used, that we have no use for, that have been sitting there for years. Some things with the office, we're filing more papers, we're cleaning out our old office, which is upstairs. It's now used as storage, but we have files dating back to the 1980s, 70s, pretty much since the company started, and we're beginning to go through all these old files and scrapping them. We got just stacks of boxes of stuff that are going to be recycled. We also worked on cleaning out the desks, all the desks in the offices, and we have a certain number of supplies that are in the offices now, or in the desks, and put away in the offices and in the cabinets. Some of the things in the desk, like no more than 2 pencils, 2 pens, a highlighter, a small sticky pad, a notepad. Everything else gets put in our file cabinet, and that allows us to track like what we have or what we need a lot easier. The next would be set in order. This is everything has a place and everything is in its place. Now, this has to do with pretty much every tool, every piece of material that we have, everything has a place, and we have to really have the self-discipline to put everything back in its place as we use it or get done with it and clean up after ourselves. Next up would be shine. Now this is a big one that we really have to work on accomplishing because it gets overlooked a lot. And so we're during downtime or while we're waiting for a machine, we're encouraged to clean up the machines, clean up the tools, not leave anything lying around, wipe things down, and really create a cleaner and working environment. Next up would be standardize. After the first three, we need to implement standards so we can maintain the first three S's. And that begins with cleaning up the shop the last like 15-20 minutes of the day, sometimes even a half hour, depending on how bad it is. And probably the most difficult one is sustaining that system. And that really comes down to self-discipline, and management has to enforce it. Now, next up would be just-in-time. Just-in-time is producing the right item at the right time in the right quantity. Anything else entails muda. Just-in-time is based on a pull system versus our push system. A push system is just we batch parts and make them, throw them on the shelves. They haven't been ordered by any customer. They just sit there and take up storage. Now, a pull system is the opposite. It's where a customer orders the part and then we make it. And this is going to create a continuous product flow, and it'll produce a link between customer demand and our production. And it eliminates our unnecessary storage, so we could probably get rid of a few of our storage shelves, create more space on the floor. And it's much more cost effective because it's linked to that customer demand. Now, like I said before, our old system, inconsistent work, our jobs are mass customized, and all of our standards are linked to those customized parts. And because we just have all these standards that can fit jobs, we have a history of batch production and over processing of parts, and we want to implement a new system, reduce that inventory. Our new system is going to consist of reduced inventory. Now, we do have some standards that will get sourced out. They'll get sourced out for EDM, honing, jig grinding, that sort of thing. There's a lot that goes into those parts. Those are some of the parts that most get overproduced. Now, we're going to be limiting that. Instead of making 30 at a time, we'll make 10 at a time and keep them stocked, but in much lower amounts. And we'll produce 10 every time. When they get down to a certain number, then we'll produce 10 more, that sort of thing. And anything that doesn't get those outsourced operations are going to either be not made at all until the customer orders them, or in even smaller amounts, just so we do have a little bit on hand just in case we get ourselves in a bind. Now, one thing that I have implemented is a work order. Now, what this is somebody from our engineering is going to write a work order to the shop, and it's going to specify the standard number, the quantity that needs to be made, and then the shop leader would delegate somebody to begin producing that, and they're going to write down how much time it took to do each process, like cut, square the stock, mill it, set up in the machine, machine runtime, what machine was used, and this will help us track the quality and improve our quality for those standards. The next thing to look at is TIMWAD, the 7 areas of waste. Now, TIMWAD stands for transportation, inventory movement, waiting, delaying, overproduction, overprocessing, and defects. Now, with regards to transportation, we don't really do much transportation at all, so there isn't really anything to evaluate at this time. It could be later on, but we're not really looking to improve that right now. Now, with regards to Wade and Delane, our products never really queue because they're so much customized, so they're so much customization that we make a lot of our parts to order except our standards. But our parts will never really queue. We have the machine capabilities to handle our workloads, but not too many machines to where they are just going to sit there all the time. Then with regards to inventory and overproduction, now we're implementing just in time, and I've implemented the work orders. Now with regards to defects, with our mass customization, a lot of our parts require in-process checks using micrometers, usually not calipers, or not accurate enough for what we do. Gauge blocks, just depends on the part, depends on the situation. A lot of them get in-process checks before our CMM certifications. Next would be movement. Now this is one of the big ones. Most of our machines are set up for efficient product flow. There are a few exceptions, such as an EDM, which we have out of place. We want to get the EDM up and running, but the one that we have, we might be looking to sell it, and then get a new one in, and then things might move around a little bit more. But right now, it's really out of place. You kind of have to walk around from the other machines around the shop to get to it, and that just creates a lot of waste with all the movement involved in that. And then another thing is we have a drill press and a sander that are out of place. It's actually behind our CNC machines and our bridge ports and against our back wall, which if we're milling something on a bridge port, you got to take 15 to 20 seconds to walk to and from the drill press or the sander, and this happens thousands of times per year. And that, it might seem like nothing at the time, but over the course of a year it adds up to hundreds of dollars per year, and that can be eliminated. We did move it to we got rid of this one table, moved the drill press, moved the sander, so it's closer, so it only takes 2 seconds versus 20. It's a lot easier, and it eliminated all that walking. And next up, the other big one is over processing. Things were getting done that were being over processed, such as oversized tapping wasn't done on the CNCs, it was being done by hand. Oversized ream holes were being done on the drill press versus setting up a reamer in a CNC so it can be done that way. Some of the things that were happening on the lathe, because the taps that they were using were dull, you wouldn't be able to tap it. It'd just spin out on the round stock, and then they'd have to get it started, finish it by hand, and that is just a lot of waste. You could take a job that would typically take an hour, would take all day, and that is a ton of wasted time. So to fix that, we bought new taps, so the parts can be tapped, and we're going to keep an eye on that and make sure that we keep sharp taps for the lathe. And then some future improvements that we're looking at, after we kind of get 5S and just in time further along, are utilizing PDCA, Plan, Do, Check, Act. This is a model for continuous improvement and will really help us. Then we have value stream mapping, which will identify value adding activities, which will help us eliminate more MUDA. And we have CPM, the critical path method, which will identify the web of activities to complete each job. Each job we can treat as a project, and the web of activities will be very similar, but the timing might be different. And it'll help us identify that and really track our processes and help us improve our time, eliminate more MUDA. And then in conclusion, we have begun to implement Lean. We still have a long way to go, but we're continuing to utilize 5S and just in time and continue eliminating MUDA. and we're looking at implementing PDCA, VSM, CPM, among any other things that will help us achieve our goals in the long run. And each day is better than the last, and that's what mentality we've really adopted. This is just the beginning. We do have a long road ahead of us.